In this chapter, we're going to review some topics in algebra that will help prepare us for the calculus course that's coming up. In this first section, we're going to review polynomial division.
All right, so the next big thing that we want to take a look at here, and again, this is just reviewing some of the rules of algebra, the procedures and whatnot that we are hoping that you know at this point here. We're going to take a look at how you find quotients between polynomials when we're doing polynomial division here. So, for example, let's take a look at this guy right here. Let's say that the question is 2x squared plus x minus 15, we'll divide that by x plus 3. Now, we're going to take a look at a handful of different problems here, and I'll show you a couple of different ways that you can approach these things. So, first of all, notice here that this is a simple quadratic in the numerator. So one of the things that I might do when I'm doing this kind of division is to see if I can factor that. Like, can I make this 2x x? Can I make this x plus 3? Can I do that? Right? So in this case right here, let's just take a look here. Now, in order to get a negative 15 at the end here, I need this to be negative 5. So that when I multiply that by that 3 there, I get the negative 15. Now let's just double check that I actually get that middle term. 2x times 3 is 6x minus 5x. Yeah, there's my x right there. So that I can cancel those guys out there. Now bear in mind that x plus 3 divided by x plus 3 is going to be 1. Okay, when I say cancel here, I don't mean they become 0, they become 1. And then the result here is 2x minus 5. Now, normally in a situation like this, I would include the fact that x cannot equal negative 3. However, that's almost implied in a question like this simply because we're asking you to do the division. We knew that there was a problem or there was a factor in the denominator. It could have led to some issues here. But anyway, that's how I would simplify that, if you can. So you factor the numerator, and then you just cancel. Okay? That should be your kind of default response to that. Now, what happens though? What happens if it doesn't look like that? What if the question looks more like this? What if we get 2x cubed, for example, minus 3x squared, minus 11x plus 6? Now, I'm going to approach this in two different ways here, okay, because I want you to be able to see both here. Oh, sorry, divided by, so concerned about the method, I forgot to actually finish the question. There we go, divided by x plus 3. Now that, oh, I'm sorry, not in this case. I've got a couple questions off to the side here that I'm looking at. I'm sorry, this one says x plus 2. I ended up looking at the original there. X plus 2, so we're going to divide that out right there. Now, we might go and use polynomial long division. And actually, this is an important skill for you to have here. So x plus 2, and then that's our divisor, and here our dividend is going to be 2x cubed minus 3x squared minus 11x plus 6. And so we're going to take and rewrite this expression as a kind of a long division sort of statement here, and I want to walk you through polynomial long division. Now, in regular long division, what you would do is you get your divisor out here, you have your dividend there, and what you're trying to do is systematically remove placeholders in your dividend from the largest placeholder down. Okay, and if you think back to what you learned way back when, you'll remember that that's how you did that. Here, we're going to do a very similar sort of thing, except instead of getting rid of placeholders, we're going to get rid of terms. Starting with the term of highest degree and then working our way down here. And this is how I do it. Okay, I'm going to compare the two terms that have the highest degree in both the dividend and the divisor here. Now, remember the way division works here. You're going to guess at something up here, multiply it, and then subtract. Well, I want that first term there to disappear when I do the subtraction here. So I need to make that x become 2x cubed. And I'm going to do that by multiplying by 2x squared. Now, just watch. 2x squared multiplied by x gets me 2x cubed. But I don't just multiply this by the first term. I got to multiply it by the whole binomial here. So this is going to become plus 4x squared. And now we subtract. 2x cubed minus 2x cubed disappears. Okay, I did that correctly. I chose wisely there. I'm going to get a 0 down here. But I have to subtract the whole binomial there. So negative 3x squared minus 4x squared will be negative 7x squared. And then, just like you would with regular long division, you bring down the rest of that polynomial. Now, I need to use this one to remove the negative 7x squared, which means I'm going to multiply that by negative 7x. So I will get negative 7x squared minus 14x. Now this becomes a little bit more difficult for people because of the preponderance of negatives here, but just be careful, take it easy. Negative 7x squared minus negative 7x squared, okay, those are going to cancel. Okay, this case is going to get me a 0 because I'm using addition subtraction. Negative 11x minus negative 14x, okie dokie, that's going to be 3x. And then bring down the 6. Just watch that you get that correct here. This is negative 11 minus negative 14. So I'm going to add the 14 to it. Now I'm almost there. I'm done when the degree of my remainder is less than the degree of my divisor. And right now they're the same, so I'm not quite done yet. So to make that x look like this, I will put a plus 3 here. Distribute that through 3x plus 6. I'm going to subtract, and actually that becomes a 0. And there you go. So there's my remainder. My quotient is 2x squared minus 7x plus 3. My remainder is 0. Now that's one way of doing this, and it works just great. Another way of doing this would be to use synthetic division. And what I tell my students here is, if you're dividing by just a beautiful little binomial like that, x plus 2, particularly if there's no coefficient out front, synthetic division is great. If there's a coefficient out front, it takes a little bit of fiddling with. I wouldn't even bother with synthetic division. I would just go right to polynomial long division. I think it's more straightforward. So anyway, with synthetic division, okay, what I do here is I'm going to draw for myself here a little box. Actually, I'll give myself lots of room here. I'm going to draw for myself a little box here. In the first row here, I'm going to put the coefficients of my dividend. And I put the coefficients of my dividend here because, you know what? Like when I do this division here, I'm dividing this polynomial by this polynomial. I already know that this is the cubic one, this is the squared one, this is the linear, this is the constant. I already know that. Do I need to write the x's down if I know what the pattern is? The answer is nah. Now, I'm going to divide by x plus 2. Now, there are two different ways that you can do synthetic division, okay? And it depends who your instructor is. So, I mean, I'm going to kind of stick true to the way I've been doing this for a long time. What I typically do is when I look at that x plus 2, most of us, when you see that as a little factor in there, immediately go to negative 2. Okay, whether that you're looking for like x-intercepts or whatever, you're kind of tuned into the idea that x plus 2 implies that negative 2 is an issue here. So what we do here is I'm going to put a negative 2 out front. Okay, and now I'll begin the process of synthetic division. That 2 drops straight down, and then you multiply negative 2 times 2, and you put the product right there, negative 4. Now, what I would do here is add. Normally with long division, right after you multiply, what you would do is subtract. But because I changed the sign here, I've already done the subtraction. So now I'm going to add here. So negative 3, negative 3 and negative 4, negative 7. Negative 2 times negative 7 gets me positive 14. I'm going to add, and I will get 3. And again, it's addition, because when I change the sign there, I've already sort of done that subtraction. I did it right at the beginning here. Negative 2 times 3 is going to be negative 6, and when I add, I get 0. Remember, that's my remainder. This is my constant, my linear, and my quadratic. So 2x squared minus 7x plus 3, just like I got before. All right, let's take a look at another one here. What do we got here? C. Whoops, make sure you can see that. So we get x cubed minus x minus 10. I'm going to divide that by x plus 4. Okay, now, the issue with this question is not necessarily a matter of method. I'm going to use synthetic division because I'm dividing by this beautiful little binomial where the leading coefficient is 1. The issue here is taking a look at what you're given in this problem here as the dividend. Now let me try to lead you into this. If I was to ask you to tell me, hey everybody, what number did I write there? Well, you would say, okay, that's a goofy question. It's 312. And I look at you and say, oh, no, 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 that's 3012. I didn't write this 0 because it wasn't important, right? 0's never important. Yeah, it is. Yeah. 3012, 312 are very, very different numbers here. The 0 is important. There is a placeholder that's missing here. Now, when you write it out, you don't typically want to write x cubed plus 0x squared, typically. I mean, if it's, in terms of the arithmetic that occurs in that polynomial, that 0x squared, don't write it. But if you're going to do division, actually, that placeholder becomes important because remember, what we're doing here is eliminating terms of sequentially smaller degree. Well, that x squared is a term, even though it doesn't show up in here. So I need to make sure that I've included, there's the cubic, quadratic coefficient, linear coefficient, and then the constant. I need to have every term represented here, because if you don't, this looks like a quadratic, linear, constant. I need to have this one in here so that in my math, I can see the structure. Constant, linear, quadratic, cubic. Now I see that this has to be a cubic here. Now I'll walk through this real quick, but that was the whole point of this question. Because it doesn't show up here in the expression of the dividend, I still need to make sure that I represent that when I do the work here. So drop down the 1, multiply, add, multiply, add, multiply, what do we got here? Negative 60, add negative 70. So there we go. So our quotient here is going to be x squared minus 4x plus 15 with a remainder of negative 70. Okay, let's take a look at another one. Look at what I've got written here. So D. So now in this expression here, I've got negative x plus 2x cubed minus x to the 4th all over, and then I'm going to divide this by x cubed minus 1. Okay. Well, when I look at the denominator here, first of all, notice that that is not just a nice little binomial. Well, okay, it is a binomial divisor. Okay, it is binomial. Don't get me wrong there. But it's not linear. Okay, that's cubic. And think about what we just did with the last question here. There are 2 other terms inside here that aren't represented because their coefficients are 0. This is not a good candidate for synthetic division, even though this is a binomial divisor. If it's a binomial divisor, I want that to be a linear binomial divisor with a leading coefficient of 1. Very, very specific. Now, I'm going to have to do polynomial long division here. So I'm going to put that x cubed minus 1 out front here. However, look at that numerator. That's just ugly. Now, if you were to be in my class here, you'd hear me comment about this all the time. These things need to be pretty in order to work out nicely for you. This does not look pretty. Pretty would be if it was written in standard form, starting with the highest degree term and going down. So I need to move that negative x to the 4th up front. And then the next smallest degree term is going to be that 2x cubed. There is no quadratic term, so I'm going to put plus 0x squared. Now look at my linear term. I've got negative x plus x. Well, those are going to legitimately cancel to create another 0. So that's going to be like 0x. And then notice that there's no constant, plus 0. Okay, so we're kind of losing the whole tail end of that polynomial there. That's okay though, that's okay. Now, I'm going to perform the division. Now, I'm going to use this term to help me get rid of this term right here. So what do I need to multiply by x cubed so that it looks like negative x to the 4th? And the answer is negative x. So I will multiply that by x cubed minus 1, and I will get negative x to the 4th plus x. Now, what I get left over is a linear term. Okay, negative x times negative 1 is going to be positive x. So I'm going to actually have to line that up with the x here. There's a gap in between. I'm not getting my cubic term or my quadratic term, and that's okay. Just consider these 0x cubed plus 0x squared. But now I'm going to subtract. Negative x to the fourth minus negative x to the fourth goes away. 2x cubed minus 0x cubed is 2x cubed. You see, if you don't pay attention to what's missing there, the in-between terms here, the fact that that drops out might elude you. You might not see that that's supposed to drop down into this next step. Now, 0x squared minus 0x squared, that actually doesn't produce anything, but I am going to put a 0x squared there because I need that to be a placeholder. 0x minus x is going to be negative x, and then I'm going to drop down that constant. Now, remember, I'm only done division when the degree of the divisor and the degree of the remainder are different, where the remainder is lower. Well, right now they're equal, so I'm not done yet. Okay, so what do I got to multiply by that to make it look like this? And the answer is 2. So 2 times x cubed is 2x cubed. But remember, it's got to go to the whole thing, not just the piece, the whole thing. So 2 times x cubed, 2 times negative 1 is going to be negative 2. But that's a constant, so I line that up with my constants. Now I'm going to subtract, bearing in mind that if it's not written there, there's still that 0x squared plus the 0x there. So 2x cubed minus 2x cubed goes to 0. 0x squared minus 0x squared, there's no x squared term, it's 0 there. No, I'm not going to write that because right away here things are going to simplify for me. Negative x minus nothing is going to be negative x. 0 minus negative 2 is going to be positive 2, negative x plus 2. So kind of an interesting little situation here. This is my remainder, okay? Right there is my quotient. Notice that the quotient and the remainder are exactly the same. Is that significant? Not really. That's kind of a coincidental that it worked here, but there's no really big significance to that. All right. Anyway, I hope that gives you a bit of an idea as to how to do division with polynomials. This skill is going to become really important for an idea that's going to pop up later in this course. Okay, so we're going to come back to this kind of with a vengeance for a little while later on.
In this next section, we're going to practice rationalizing the denominator.
Okay, now I want to talk about rationalizing. Now, in your past experience here, you've used rationalizing to deal with a radical typically that shows up in the denominator of a fraction. Now, just to explain really quickly what's going on here, let's say that I have, let's say I've got, for example, root 10, and I'm going to divide that by 5. That makes sense, okay? It's very easy for me to take a line segment, for example, that's root 10 units long, and I can now divide that into 1, 2, 3, 4, okay, I did that wrong. 5, there we go. 1, 2, 3, 4, 5 equal line segments. That makes sense to me. I get that. Okay? However, what if we reverse that? What if we take 10 and divide that by root 5? What does that mean? Well, it means we take a length of 10 and we divide it into root 5 different pieces? Well, how many pieces is that? I don't know. I don't know. And in fact, that root 5, that's an irrational number. The decimal goes on forever. I can never even exactly write that as a number. I mean, that's the best that I can do. So the idea of dividing by an irrational number, it doesn't really sit well. And so that's why we have this process of rationalizing. Now, however, in our modern day, we've got these tools. If I was to ask you to divide 10 by root 5, most of you wouldn't look at me and go, that's a conceptually difficult problem, Mr. Clausen. No, what you would do is you'd go to your calculator, go 10 divided by the square root of 5, and you'd say, okay, what's the problem? It's 4.47 roughly. Well, yeah, okay, I get that. Now, that doesn't alter the fact, though, that particularly in this course, the idea of rationalizing is still quite important. But it's not so important because there's a conceptual issue with dividing by an irrational. The issue has to do more with moving a radical from one part of an expression to another, from basically the numerator to the denominator or vice versa. So to start off with here, I should say it like this, the goal here is really just to get you familiar or comfortable again with this idea of rationalizing but in an algebraic, less, not so much an arithmetic sense. So algebraic meaning I'm just going to have variables in here as opposed to just using numbers. So to start off with, let's do a really, really straightforward one. Let's say 4x squared divided by the square root of 2x. Okay, now actually, I can do this a couple of different ways. Because I could simplify 4 divided by root 2. Okay, because actually I can do that. And then x squared divided by x to the 1/2. But let's walk through the expectation here. What we're supposed to do here, the idea behind rationalizing is I need to get rid of that radical down there. Now this is a square root. It's a monomial, so to get rid of that I would square it. But you can't just multiply the denominator by root 2x and think that that's okay. No, I got to multiply it by root 2x over root 2x. So that really, what have I multiplied by? What is that factor? 1. Multiplying by 1 does nothing. So the goal here is to rewrite this thing so it looks different without doing anything, without actually changing the value of the expression. Now, in the numerator, that becomes 4x squared multiplied by the square root of 2x. But the denominator, root 2x multiplied by root 2x, is going to be 2x. Okay, that is the nature of the square root, right? When you square the square root, you regain the original value here. Now, there are obviously some restrictions here on the variable that would pop up here. You know, x has to be greater than 0. Okay? That would still be the case up here. But now I would simplify that. 4 divided by 2 is going to be 2. X squared divided by that x would be x. Square root of 2x. Okay, now I canceled the x's here, so there would be this restriction that x can't be equal to 0, and I've lost that. So I do need to include here that x can't be equal to 0, because that was part of the original function here. But part of the original expression here, but the original expression also had this restriction that x had to be greater than 0. That's still maintained. Okay, the negatives are still an issue here, but this is the only one that I can no longer see clearly. So I want to state that. Okay, let's look at another one. Let's rationalize this guy. So x squared minus 4x over the square root of x minus 2. Now hopefully you heard what I said in that last one and that we can discuss what's going on here. I've got x squared minus x divided by the square root of x minus 2. The denominator has got this radical in it. Now what I need to do here is get rid of the radical. But it's a monomial. Okay. Now I recognize that if you ignore that radical there, okay, you've got this x minus 2, and that by itself is a binomial. But that bar over top implies a set of brackets that hold that together a little bit more firmly. That actually is one term there. So how do I get rid of a radical in the denominator, especially if it's a monomial? Well, I square it. Okay? And so when I do that, I'm going to multiply this whole thing by the root of x minus 2. Now I got to put brackets around that x squared minus 4, because that's the only way I can clearly communicate that this is multiplied by both parts. Okay, it's the whole thing. If you drop the parentheses, you're only multiplying that radical by one part of that. In the denominator, you're going to be left with x minus 2, which is great, which is awesome. Now, there's always a little bit of simplifying here. Notice that x squared minus 4 is a difference of squares, and that denominator you should recognize as being one of the factors. So x minus 2, x plus 4, square root of x minus 2, all over x minus 2. And now I can see that that factor will cancel to produce a 1. Oh, whoa, I have no idea why I wrote a 4 there. That's just crazy talk. Okay. X plus 2 multiplied by the square root of x minus 2. I dropped the x minus 2's, which means I've actually lost the restriction that x can't be equal to 2, so I have to include that. But the fact that it's got to be greater than 2 is still there because of the radical. Good. Let's do another. Okay, let's just take a quick look here which one I wanted to do. I wanted to do this one. 8 divided by the square root of 4 plus x minus the square root, square root of x. All right, now the reason why I wanted to do this one right here is because the denominator here is a binomial. Okay? It's not a trinomial, it's a binomial. That radical keeps those two values together. Okay? Now, if I was to square that, squaring would not eliminate the radical. Let me show you. I tell you what, let's just do it over here. If I take root a plus root b, okay, and I square that, well, that's like multiplying root a plus root b. Root a times root a is a. Root a times, root b will be root ab. Root b times root a will be root ab. Root b times root b will be b. And so this becomes a times 2 root ab plus b. Notice that when I squared that binomial, even though it had radicals in it, when I squared it, it did not get rid of the radicals. I mean, I have fewer of them, but it didn't get rid of the radicals. If you square a monomial with a radical in it, it will get rid of the radicals. But if you square a binomial, it won't. That doesn't work. So we need a different method. Now, which is why, and hopefully you're familiar with this, so I don't have to go through and explain all that, we are going to multiply by the binomial conjugate. Because what that does is create a difference of squares, okay, in that denominator. So the numerator will be 8 multiplied by, and I will just leave that in brackets there. Okay, root 4 plus x plus root x all over. Now, when I multiply these out, because these are binomial conjugates of each other, I am going to get the first term squared minus the second term squared. So I am going to get, and I'll write this out, and hopefully everybody will catch what I'm doing here. This will be root 4 plus x squared minus root x squared. So that is going to give me, there's my numerator. I'm not doing anything with the numerator quite yet. That's going to get me 4 plus x, because the square there and the square root will cancel each other out, minus x. Now look at that. The x's will cancel, and then 8 divided by 4 will get me 2. So this is going to become 2 multiplied by the square root of 4 plus x plus the square root of x. Okay? Now, there might be some restrictions implied in there, but for right now, I just want to get the idea, this pattern here. Mostly because when we start to apply this in calculus, some of these issues with restrictions, they don't even pop up. Okay, so I'm not going to worry about the restriction right now. I just want you to get the procedure. In the last couple questions, it made more sense to kind of just throw that in there. But now, I just really want to focus on that pattern. Let's take a look at another one. Okay, x over the square root of x squared plus 1 plus x. Now, actually, I'm going to rewrite this one because I want the issue to be like abundantly clear here. So x divided by the square root of x squared plus 1 plus x. Okay, now when I ask someone to rationalize this for me, I will often get people that will do this wrong. They'll say, oh, it's the square root of x squared plus 1. Oh, that's so easy. The square root of x squared is x. Square root of 1 is 1. Then we get the plus x. Look, this is so easy. It's because you did it wrong. Okay? And if you look at me and say, what? I did it wrong, but I always do it like that. Well, then the answer is you always do it wrong. You've always done it wrong. You can't take the square root like that. The square root, okay, everybody, the square root of 9 plus 16. The way a lot of you approach this, you go, oh, that's easy. 3, 4, 7. Booyah. Now, most of you would look at that and say, oh, no, that's not how you do that. You add those together first, and then you take the square root, you get 5. So why is it that people are so willing to add if you see numbers? You add first when you see the numbers, but as soon as you see a letter in there, you don't. You take the square root first. because this is an order of operations issue. You actually have to do the addition before you can do the radical. That bar up top there implies a set of brackets, and you do what's inside the brackets first. I square the x and add 1 before I take the square root. Now, because I don't know what x is, I don't know what x squared is, I certainly don't know what x squared plus 1 is, I can't take the square root because I don't know what that number is. That is a dead end. I can't move on from there. It's an order of operations issue. Okay, please don't do that. Don't do that. The only way that you can get around this problem is by multiplying by the binomial conjugate. So I have to multiply by the square root of x squared plus 1 minus x. Okay, whoops, I wrote that way too big. The square root of x squared plus 1 minus x. Now up in the numerator, I would be very tempted to leave that x out front just for the time being to see what happens here. In the denominator, okay, because I'm using binomial conjugates, and I've already shown you this pattern here, when I multiply the first two together, the square roots will disappear. Subtract the square of the second term, so that's going to be minus x squared. Okay, x times, positive x times negative x, there's my negative x squared. So the x squared terms will cancel. This will all be over 1. So you're left with x multiplied by the square root of x squared plus 1 minus x. And I don't exactly know what you're going to do with this next here, so you might be able to get away with just leaving it like that. That would be fine. All right, let's do one more. Let's do one more here. X squared over, let's say, the square root of x plus 1 minus the square root of x minus 1. Okay, once again, this is a binomial in the denominator. The subtraction in between, remember the square roots, keep those together. So the way I simplify this is to multiply by the conjugate of the denominator. Now, there's a bunch of terms here, well, at least looks like a bunch of terms. These signs inside here don't change. It's only the sign in between those two terms. You got to really see this clearly. There are two terms here, not four. So it's just the term in between that changes when I create this binomial conjugate. All right, so now the numerator will become x squared multiplied by, and then brackets, root x plus 1 plus root x minus 1. Now the denominator is going to be the square of the first term minus the square of the second term, and the squares are going to remove the radicals. So it'll be x plus 1 minus, okay, now here's where I need to be really careful with this. I am subtracting a binomial, not just the x. So if you did this, if you go, okay, minus x minus 1, that's wrong. Because what have I've subtracted here? I'm supposed to subtract x minus 1, but all I've done is subtracted the x here. That negative should distribute through. This should become x squared multiplied by root x plus 1 plus root x minus 1. All over. That negative should distribute through, so I get x plus 1 minus x plus 1. Okay? If I don't put the parentheses there, then I'm not subtracting x minus 1, I'm subtracting x and then adding the negative 1. Because I don't change the sign. The subtraction should change the sign on that negative 1. It should distribute through here. Now the x terms will cancel. I'm going to end up with 1 plus 1. I'm going to end up with a 2 in the denominator. So x squared multiplied by the square root of x plus 1 plus the square root of x minus 1 all over 2. That's where that goes. Okay, now we're going to take a look at this from in a slightly different direction.
In this last section, we'll rationalize the numerator.
Now you should also be aware that we can rationalize the numerator. You don't often do that, but bearing in mind that the goal here is simply to move the radical from one part of the expression to the other. Well, sometimes we want to move it from the numerator down to the denominator. Now, prior to this point, you haven't had kind of a context for that. You'll see. When we get to the next chapter in this course, you'll see where this pops up here. So let's take a quick look. So say we had a question like this, root x minus 3 over x minus 9. Okay? Now, this time the radical's in the numerator. It's a binomial, so I'm going to multiply by the conjugate. Numerator and denominator by the conjugate. So down in the denominator, we're going to get x minus 9, and then root x plus 3. And then in the numerator, we're going to see that difference of squares kind of pop out here. So root x gets me x, negative 3 plus 3 will be negative 9. And now the x minus 9s are going to cancel. So I'm left with the square root of x plus 3 in the denominator. I really should include, in this case, and it's very simple to do this one, I should really include the case that x cannot equal 9. Okay. Now, in previous questions, you'll notice that I didn't worry so much about the restrictions. Some of them I did, some of them I didn't. When it's just really straightforward like that, and I can see it very clearly right away, I'll just write that down because I'd feel goofy if I didn't. That restriction, once again, when we start to actually apply this little procedure, it's really not going to be that important. And you'll understand why when we get there. You'll see where that shouldn't even pop up. Let's take a look at another example here. Let's say I've got x root x minus 8 over x minus 4. Again, there's a binomial in the numerator. And I am going to multiply by the conjugate. I'll multiply numerator and denominator by the conjugate. Now, in the denominator, I will get x minus 4 multiplied by x root x plus 8. Okay, the numerator, when I apply that and start to look at this as a difference of squares, x root x multiplied by x root x is going to be x cubed. Just be careful you think that through here. Oftentimes I'll see people tell me that's x squared because they forget to square the x itself out front. They're pretty good with the root x multiplied by root x is going to give you x, but they'll forget that x times x out here is going to give us x squared. So put those together, you're going to get x cubed, and then negative 8 times 8 will give us negative 64. Now at this point in time, for right now, I'm not entirely sure what everybody else's background is, but with the school that I'm at right now, we haven't specifically looked at a tool for factoring this. I will get to that shortly. We're not exactly done this. There's a little bit of simplifying that can occur here. Just wanted to point that out. Okay, we will get to that shortly. So for right now, I'm going to just kind of walk away from that problem. That's what we did, multiplied by the conjugate of the numerator. Okay, oops, not D. C. We'll do one more. And just so that you've seen a question that looks like this, what if I asked you to rationalize the numerator? And what I wrote was that. Okay, now a lot of times people will look at this and get kind of say, what? But remember that any expression like this can be written as a rational by simply putting it over 1. And then what I'll do is I'll multiply by the binomial conjugate. So the square root of x squared plus the square root of x squared minus x. And we do that numerator and denominator. So now down in the denominator, it's just going to be the square root of x squared plus x plus the square root of x squared minus x. But in the numerator, I'm going to apply that pattern, the difference of squares. So I'm going to get x squared plus x, and I'm putting it in parentheses here, not because it was necessary here, but it will be necessary in the next step because I'm going to subtract x squared minus x. And I want to make sure that I subtract the whole thing, not just the first term. So now I'm going to drop the parentheses by distributing the negative through the entire second term. In that way, I have actually subtracted everything. I've subtracted the x squared, and I've subtracted the negative x. And that's why it became positive. And in your denominator, at this point, I'm not going to do anything else to it, so it's going to stay the same. My numerator, x squared minus x squared, goes away. X plus x is 2x. So we get the square root of x squared plus x plus the square root of x squared minus x. Oops, there you go. So there, I just need you to understand that rationalizing can apply from the denominator up or the numerator down. Okay?